The automotive industry always loves a grand reveal. We measure it in the 90 seconds a covered car spends spinning on a turntable under perfect lighting, built entirely for the camera lens. But the published schedule tells a completely different story. Look at the Los Angeles Auto Show. You get exactly 1 day of pristine, controlled press access. Then you get 10 days of the general public. When those doors open at the convention center, several 100,000 people flood the floor. The public portion of the show transforms the venue into a brutally compressed physical wear test. Think about the physical toll of that massive crowd. Every single door is opened and closed thousands of times. Every seat is climbed into by people wearing heavy coats, carrying large bags, dropping weight from unexpected angles. A laboratory test is controlled. This environment is hundreds of thousands of uninstructed strangers interacting with an object exactly how they want to. And what actually fails under all that pressure? It is never the powertrain. The engine and chassis survive. The failures are intimate. It's the door check strap that goes completely vague. It's the high-gloss trim developing a haze of micro-scratches under the harsh stand lighting. It's the entry side of a seat bolster crushed flat by day 3. Or it's a single switch on the dashboard, a button that after 10,000 presses loses internal resistance, feeling like a toy. Why do millions of dollars of rigorous engineering and pre-production fall apart after a few days of basic human touch? When a switch fails on a stand, the immediate reaction is logistical. A show team can easily swap in a fresh replacement part overnight before doors open again. But a new switch doesn't solve the problem. You can replace a worn component, but you cannot make the mechanism inherently feel any better. That physical crispness under your thumb is a mechanism decision, dictated entirely by the detent's internal geometry and spring tension. These variables are frozen the moment the switch is engineered. By the time it breaks on the show floor, it's too late to change. The same logic applies to that scuffed dashboard trim. Whether a surface acquires a visible haze is a materials decision, relying on hardness and coating choices made long before anyone saw the finish on a stand. Regardless of how well a part is manufactured, the tactile failure seen on day 9 is often a legacy of the drafting table. The moment the underlying physics are locked in, the part's response to 10,000 cycles is already being dictated. Let's trace that crushed seat bolster backward. We must move away from the chaotic show floor and return to the pristine drafting table. Whether a seat survives is a matter of ingress geometry, the sill height, aperture shape, and B-pillar location. People carrying bags don't slide in perfectly. They navigate these unforgiving boundaries, and every physical friction point takes the damage. And the history of automotive exhibitions shows this has always been true. Deep, unmitigated physical access to products is the reality of sustained dwell time. By the time any car reaches a turntable to impress the media, every single one of those foundational architectural decisions is already years old. The trade show floor strips away the marketing, exposing flaws in the core architecture that have been hidden for years. If a public stand is a wear test, then you have to design for the test that is actually run. We have to stop designing ingress for a pristine mannequin in a package drawing and start designing for a stranger in a winter coat carrying a heavy bag. Tune detents for heavy thumbs, specify touched edges for rough handling, and choose gloss for brutal lighting. None of this is show preparation. Every single one of these preventative actions traces back to a single point of origin, the concept phase. Depix provides the environment to simulate mechanical outcomes and material behaviors long before physical manufacturing begins. This process lets design teams foresee the physical toll of human interaction, mitigating friction points while the product is still a highly adaptable digital model. Design decisions are cheap as a sketch, but brutal once tooled. You must see every angle before you build.